Okay, so today I want to go over some more about the Lewis dot structures. And last night, what you should have done was you should have watched the screencast about beginners covalent Lewis dot structures. You should have seen the NASL method. Um, you should have seen me go through some of those calculations with that. You should have also seen the honk rule and have a little bit of understanding of what that is. So I'm going to show you now how to um, how to figure out Lewis dot structures, and I'm going to show you both a visual way and then using NASL and kind of give you some pointers on what you should be thinking about. So to help you with this, I'm going to pick two structures, and this is from the handout which I included in your packet, which includes the NASL method. And I'm going to just choose two at the bottom here. And these are not assigned for homework at any point, but they are here if you ever want to go back and just do them just to get some extra practice. One of these, water, is on the homework, so that will help you with the homework. So you might want to write this down here as we go through it. The other one I don't believe is in your homework at all. So let's look at water. So when you're doing these, if you're doing it visually, first you start out with your molecules. So we have H2O. And even if you're not doing the NaSl method, it is very important that you're figuring out how many electrons you have available for your structure. So available is really talking about your valence electrons. So the valence electrons are the only electrons that are used by the atom when it reacts. These are involved in bonding. So in our molecule, the electrons that we see in the bonds and also our lone electrons are actually just our valence electrons from those different atoms in the molecule. So if we look at hydrogen, we know from the periodic table, hydrogen is in group 1. We have 2 hydrogens. So 2 times 1, because group 1 elements all have 1 valence electron, so 2 times 1. We have 1 oxygen, and oxygen is in group 16. Everything in group 16 has 6 valence electrons. So this tells us we have 8 electrons involved, 8 electrons available to form the bonds and also lone electrons in our molecule. The next thing we have to think about is what atom to put in the center. Usually the first atom in your formula will be the central atom. However, it is also important you remember things like hydrogen. Hydrogen will never be the central atom because hydrogen, according to the honk rule, hydrogen is first as well as halogens like to only have 1 bond. Oxygen, as you know, is the second. It likes to have 2 bonds. So it would make sense to have oxygen in the center so it could have 2 bonds around it. So we're going to put oxygen in the center. Nature likes symmetry, so we're going to put hydrogen on either side of oxygen. And when we do it visually, we just start out with single bonds going out from their central atom to the atoms in our molecule. Next, we're going to evaluate it and see if different atoms in the molecule are now stable. Hydrogen, remember, hydrogen likes to have a duet of electrons so that it can look like helium. This makes it very stable. So that's why we say hydrogen satisfies the duet rule. Now, hydrogen and oxygen are sharing electrons. Each of these can claim the electrons in the bond next to it. So each hydrogen has 2 electrons. That line represents 2 electrons. So I'm just going to label that in blue. This represents 2 bonding electrons. So each hydrogen in this molecule has 2 electrons. Oxygen only has 4 right now. And remember, oxygen wants to have an octet of electrons. Oxygen wants to have 8 electrons around it. Right now, oxygen only has 4, so we're going to have to add 4 more electrons, which will be non-bonding electrons to oxygen. So we're going to add dots to it. Now, if we look at this, oxygen has 2 in that bond, 4, 6, 8 electrons. Oxygen has an octet of electrons. We also think about the Honk rule. Oxygen has 2 bonds attached to it, so it satisfies the Honk rule. We see that each hydrogen has 2 electrons. Also, if we look at our available electrons, we see that the molecule has 2, 4, 6, 8 electrons, which is the correct number of electrons according to our valence electrons. So this is the structure for water. Now let's look at CS2. That was the other one I pointed out on the sheet. So CS2. I'm going to show you also how to do this one visually. So the available for CS2 is going to be 4. That's for carbon. And we have 2 sulfurs. Each sulfur has 6 electrons available for bonding, or 6 valence electrons. So we have 2 times 6 is 12, plus 4 is 16. So we have 16 electrons available to use in our structure. So again, usually the first one in the formula is in the center, but also think about the Honk rule. You can also think about which one has a lower electronegativity. All of those will help you to figure out which one to put in the center. So carbon is going to go in the center. And we're going to start out by putting the 2 sulfurs on either side to make it symmetrical. And always, like I said, start out with single bonds when you're doing it visually. And then check to see that each atom in your structure satisfies the octet or the duet, or if you have boron, remember boron needs 6, or if you have beryllium, that needs 4. So the 3 exceptions for your elements are hydrogen needs 2, boron 6, beryllium needs 4, rest need 8 to be stable. And remember, the goal is they all want to look like a noble gas. Most noble gases, with the exception of helium, have 8 valence electrons, and it makes them stable. So if we look at our structure right now, each sulfur only has 2 electrons. Remember, those lines, those bonds, represent 2 bonding electrons. So to make sulfur stable, we're going to have to add 6 more electrons around it to give each of those sulfurs 8. Carbon in the middle only has 4 electrons around it right now. Remember, each of those lines represents 2 electrons. Carbon is sharing them with sulfur, so carbon can claim those 4 electrons in those 2 bonds. And then we need 4 more electrons to make carbon stable. Now, if we count the number of electrons we're using, we should have 16 electrons if our structure is using the correct number of electrons. So let's check. We're using 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We're using too many electrons. If you're doing this visually and you run into this, what you have to do is you have to start adding double bonds or triple bonds. So when you do this, you're going to erase 4 of your electrons, 2 electrons on either side of a bond, and replace that with a double bond. So let's erase 2 electrons here, 2 electrons here. So we erase 2 from sulfur, 2 from carbon. And then we're going to add a double bond between sulfur and carbon. We then recount and see if we're using 16. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18. We're using too many electrons. So we're going to erase 4 more and add another double bond in our structure. So again, we're trying to make it symmetrical. So we want to add a double bond on each side, not like a single bond and a triple bond, to make it more symmetrical. So we're going to add a double bond there. And then if we check again, 2, 4, 6, 8, 10, 12, 14, 16, which is the correct number of electrons. We also think about the Honk rule. We notice here carbon has 4 bonds. Remember, it's last in the Honk rule, which means it likes to have 4 bonds. Each sulfur is in the same group as oxygen. So oxygen and sulfur in the group 16. Everything in group 16 that's a nonmetal likes to have 2 bonds. So oxygen and sulfur both like to have 2 bonds. So here it has 2 bonds. We also check to see if we're satisfying the octet rule for each. So we see that sulfur has 2, 4, 6, 8 electrons. Carbon has 2, 4, 6, 8 electrons. This sulfur has 2, 4, 6, 8 electrons. So everything satisfies the octet rule. We're satisfying the Honk rule, and we're using the right number of electrons. Now, you could have also figured out that you needed double bonds in this if you did the NaSl. So if you're having a hard time figuring out when you need to do double or triple bonds, then I highly recommend that you do the NaSl. And I'll show you now how that would also tell us that we needed some double bonds. So if we did do the NaSl for this, we would get the needed would be 8 for carbon because it likes to have 8 when it's done. It satisfies the octet rule. We have 2 sulfurs. Each of those need 8. And they all satisfy the octet rule. So this would give us 24 electrons. And this is just the needed really doesn't mean anything as far as our structure. It just helps us with our math calculations for the NaSl method. A, we calculated up here. That's going to give us 16. S, remember, is N minus A. That's going to be 24 minus 16. That's going to be equal to 8. And then A minus S is equal to lone. That's going to be our dots on our structure, those dots. We do 16 minus 8, which gives us 8 dots. If we look at our NaSl calculations, if we divide that 8 by 2, we see that we have 4 bonds. And if we look up here, we see we have 4 bonds. The 4 bonds in this case are 2 double bonds. We see that we have 8 lone electrons. If we look up here, we see we have 2, 4, 6, 8. So if we had done the NaSl calculations, we would have also come up with this structure using these calculations. Okay, so on your homework, you're going to be doing you're going to have to be thinking through this thought process as you work through the structures. These are kind of like puzzles. It does take a little while to get the hang of it for some students it comes very naturally. The ones that you're doing tonight, you're not going to do anything with polyatomics, nothing with charges tonight. You're also not going to do expanded octets. So I want you to try your best on these. Don't worry so much if you're not sure if they're right or not, but try to struggle through them, think through these processes. Like I said, each time at least calculate your A each time. Think about your octet rule or duet rule or these other exceptions each time. Make sure you're only using that available in your structure, and also think about the Honk rule each time. So if you're having any problems with this, please make sure you're coming to tutorial or office hours, and I'd be happy to help you with it. So good luck on this.